Hi friends, welcome to Ajis Academy. Today we are going to discuss some multiple choice questions in sequences and series. I prepared these multiple choice questions from the latest university question papers. Okay. Question number 1. The LUB of the sequence 1 by 2, 2 by 3, 3 by 4, etc., n by n plus 1, etc. is. This type questions first verify whether the sequence monotonic increasing or decreasing. Okay, first you fix the monotonic sequence. Then if it is monotonic increasing, then the first term is the greatest lower bound. Okay, here they are given monotonic decreasing sequence. So the first term 1 by 2 is the greatest lower bound, but they are asking the least upper bound of the sequence. So in that problem, we take the nth term and cancelling the n's. So we will get 1 by 1 plus 1 by n, and applying n tends to infinity, we will get 1 by 1 plus 1 by n. So when n tends to infinity, the answer is 1 by 1, and therefore the LUB is 1. Okay. Then question number 2. Limit n tends to infinity 1 by 2 power n. So it is very easy. Answer is 0. Question number 3. Limit n tends to infinity sin n by n. So this is a repeated question. So for this problem, we can use one important problem that if sequence an converges to 0 and sequence bn is bounded, then the product sequence an bn converges to 0. So here sequence an is sequence 1 by n. Clearly it converges to 0, and sequence bn equal to sequence sin n, it is bounded, and therefore by that problem sequence sin n by n equal to 0. Okay, so option for question number 3, the answer is 0. Question number 4. Limit n tends to infinity n by square root of n square plus 1. So this type problems we can take, or we can cancel highest powers of n's if it is possible. Then applying limit n tends to infinity, we will get the answer is, here the answer 1. Question number 5. The sequence 1 by n is a dash. So here options divergent, oscillating, Cauchy, not Cauchy. So we know sequence 1 by n is a Cauchy sequence. Question number 6. Any convergent sequences. So this is a important theorem that any convergent sequence is bounded. Answer is bounded. Question number 7. The series sigma 1 by n log n dash. By Cauchy's condensation test, the series diverges. Okay, yeah. So whenever one series consists log terms, so it is better to prefer Cauchy's condensation test. So, and also the series sigma 1 by n log n, very familiar in Kummer's test and its corollaries. Here the answer is diverges. Question number 8. The series sigma x power n by n power n. By ratio test, the answer is here converges. Question number 9. One alternating series is given. So alternating series is always, they are given in 1 mark questions. So whenever one alternating series is given and they are asking the convergence, so you may learn the Leibniz test. Okay, so what is the Leibniz test? Sigma minus 1 power n plus 1 an converges if it's satisfying two conditions. First one is sequence an monotonic decreasing and limit n tends to infinity an equal to 0. Okay, so here an is n plus 1 by 2 power n. Clearly sequence an monotonic decreasing and limit n tends to infinity equal to 0. So by Leibniz test, the answer converges. Question number 10 is also a also an alternating series. So here an is 1 plus 1 by n, clearly sequence an monotonic decreasing, but limit tends to infinity an not equal to 0. In this case, sequence, the given alternating series oscillates. Okay, whenever sequence an monotonic decreasing and limit an not equal to 0, then Leibniz test says that the series alternating series oscillates. Question number 11. The following statements are true except. Here option A, sequence 1 by n convergent is true. Option 1 by n bounded also true. Sequence 1 by n is monotonic increasing is wrong. Okay, so in question number 11 they are asking the false statement. So sequence 1 by n is a monotonic increasing is wrong. So option C is the correct answer. Question number 12. Read the following statements. So here some theorems, important theorem statements are given below. We are all know that any convergent sequence is Cauchy. Any Cauchy sequence is convergent. Okay, so they are given the statements related to convergent, Cauchy, bounded. And here 4 options are also given. So here option A is the correct one. Only 1 and 3 are true. 2 and 4 are wrong options. Okay, so option A is the correct answer. Then question number 13. The incorrect statement from the following. Here 4 series are given below. So read carefully and mark the incorrect statement. Here option D is the correct one, that is sigma 1 by n converges to 2 is the wrong answer. Question number 14. Here they are given two statements. In statement number 1, the series sigma 1 by n power p converges if p less than 1. In statement number 2, the series sigma 1 by n power p converges if p greater than 1. We know one important theorem says that sigma 1 by n power p diverges if p less than or equal to 1, and the same series converges if p greater than 1. So here statement 2 is correct, but statement 1 is wrong, and therefore the option A is the correct one, that is only 1 is false. Question number 15. 1 plus 1 by 2 plus 1 by 2 the whole square plus etc. So here this is a geometric series with the common ratio 1 by 2, and we have the sum is 1 plus 1 by 2 plus 1 by 2 the whole square plus 1 by 2 the whole cube plus etc. equal to 1 by 1 minus 1 by 2. So answer is 2. Option A is the correct one. Question number 16. Limit tends to infinity 1 by n, 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n equal to what? So we know by Cauchy's first limit theorem, here an is 1 by n. We know sequence an equal to sequence 1 by n converges to 0. Because Cauchy's first limit theorem says limit tends to infinity a1 plus a2 plus etc. plus an by n is also converges to 0. Okay, so the answer is option A is the correct one. Question number 17. Let sigma an be a series of positive terms. The correct statement from the following is, read carefully. So here the option A is the correct one. Sigma an converges if limit tends to infinity an by an plus 1 greater than 1. So this is the ratio test. Then question number 18. Applying the ratio test for 1 plus 1 by 1 factorial plus 1 by 2 factorial plus etc. plus 1 by n factorial plus etc. The series is option A is the correct one, convergent. Question number 19. Applying the ratio test for limit tends to infinity 1 plus 1 by 1 factorial plus 1 by 2 factorial plus etc. plus 1 by n factorial equal to dash. Answer is E. Small e is the correct one, option C. Question number 20. Limit tends to infinity 1 cube plus 2 cube plus etc. plus n cube divided by n power 4. Okay, if you know the formula for numerator and the denominator, you can apply the formula first. Here 1 cube plus 2 cube plus etc. plus n cube is n plus 1 by 2 the whole power 2. Okay, then take the highest powers of n's and cancelling the same if it is possible and applying the limit, you will get the answer is what? Answer is 0. Then question number 21. Question number 21. The range of the sequence 1 plus minus 1 power n is dash. Easy question. Range means set of all terms of the sequence. Set of all first term, comma, second term, comma, etc. So here the range of the sequence is 0, comma, 2. So you put the set bracket is compulsory. Set of all 0, comma, 2 is the answer. Question number 22. The value of limit n tends to infinity 2n plus 1 by 2n. Answer is here we can apply limit tends to infinity. Before that, cancelling the highest powers of n, we will get answer is 1. Question number 23. The value of limit tends to infinity 1 plus 1 by 2 plus etc. plus 1 by n. Answer is infinity. This is a repeated university question. Question number 24. Which of the following is a Cauchy sequence? So here sequence 1 by n is Cauchy. Option A is the correct one. Question number 25. Sequence 2 power n is a dash sequence. Option B is the correct one. That is divergent sequence. Question number 26. The geometric series sigma r power n converges if. So here the option C is the correct one. 0 less than or equal to or less than 1. Question number 27. If sigma an converges to yes, then option B is the correct one. Limit tends to infinity an equal to 0. Important result. Question number 28. If an equal to 2 power n into n factorial divided by n power n, then limit tends to infinity an by an plus 1 is dash. Here the option D, E by 2 is the correct answer. Question number 29. The sequence minus 1 power n is a dash sequence. We know that the terms of the sequences minus 1 plus 1 minus 1 plus 1 etc. Clearly this is a bounded sequence, not convergent, not monotonic, not divergent. Answer is option A. Then question number 30. The limit of the sequence 1 by n is 0. Easy question. Question number 31. A monotonic increasing sequence which is bounded above converges to its LUB. It is a very important theorem. LUB. Question number 32. Which is Cauchy sequence? So here option 1 by n is a Cauchy sequence. Repeated question. Question number 33. The series 1 plus r square plus etc. plus converges if dash. So here option B is the correct one, 0 less than or less than 1. Question number 34. The series sigma 1 by n power p diverges if. What is the answer here? Diverges if p less than or equal to 1 is the correct answer. Option D is the correct option. Question number 35. If sigma an converges, then sigma an by n. They are asking the convergence of the series sigma an by n whenever sigma an converges. So this is by Abel's test. The answer is sigma an by n converges. Option A is the correct answer. Question number 36. If sequence an converges to A and sequence bn converges to B, then which one of the following are true except? So here option A, B, C are all true and option D is not true. So here option D is the correct one. Question number 37. If an equal to n factorial by n power n, then limit tends to infinity an by an plus 1 equal to dash. Option D, 1 by e is the correct answer. Question number 38. In R, every Cauchy sequence is convergent by Cauchy's general principle of convergence in sequence part. So the answer is convergent. Question number 39. The series sigma minus 1 power n plus 1 into n by 5n plus 1. This is an alternating sequence. This is an alternating series. So we can use Leibniz test and find the limit tends to infinity n by 5n plus 1. Here answer is non-zero. Therefore answer C. Option C, oscillates, is the correct answer. Question number 40. The set is set plus of positive integers 1, 2, 3, etc. Okay, so they are asking, is it bounded above, above, bounded below, unbounded below. So this is bounded below by 1 but not bounded above. Okay, answer is bounded below. Then question number 41. If a and b are real numbers, then modulus a plus b greater than or equal to, so simple one. Answer option B is the correct one, that is mod a minus mod b. Question number 42. Limit tends to infinity n square plus n plus 1 divided by n cube plus 2. Here the power of n in the denominator is exceed than the power of n in the numerator, and therefore the answer is 0. Question number 43. Limit tends to infinity n power 5 divided by 2 power n. Answer is 0. Question number 44. The series 1 by 1 into 2 minus 1 by 3 into 4 plus 1 by 5 into 6 minus 1 by 7 into 8 plus etc. So this is an alternating series, and therefore you can first try to write an and verify whether the two conditions are satisfied, that is sequence an monotonic decreasing and limit an equal to 0. The two conditions are satisfied here, therefore the answer is converges by Leibniz test. Question number 45. The LUB of the sequence 1, 1, 1 minus 1, 1 minus 1, etc. Here the LUB is plus 1. Answer is 1. Question number 46. Limit tends to infinity n plus 1 into n power n divided by n plus 1 the whole power n plus 1. Okay, we simplify first and then applying limit, we will get the answer 1 by e. It is very simple. Question number 47. Limit tends to infinity n plus 1 by n into 1 by x. The answer is 1 by x. Question number 48. Summation minus 1 power n plus 1 into an, where an greater than 0 is an dash. So clearly this is an alternating series. The answer is alternating series. Question number 49. Modulus sin theta always less than or equal to 1. So answer is less than or equal to 1. Question number 50. Limit n tends to infinity n power 1 by n. So this is a repeated university question. Answer is 1. Question number 51. Limit tends to infinity x power n by n factorial equal to dash. Answer is 0. Question number 52. The series sigma 1 by n. So answer is diverges. Question number 53. The convergence of the product of two series is described by which one of the following theorems? So here option B, Abel's theorem, is the correct answer. Question number 54. Every convergent sequence is bounded. Option A is the correct answer. Question number 55. The sequence n by n plus 1. The sequence n by n plus 1 is dash. So here option C is the correct one. Since it has LUB and GLB, and therefore sequence n by n plus 1 is bounded. Question number 56. Limit tends to infinity 2 power minus n into n square. It can be expressed as limit tends to infinity n square by 2 power n. The answer is 0. Question number 57. The series sigma root n square plus 1 minus n is dash. In this type questions, we must write the conjugate and simplify. Finally, we will apply the appropriate theorems, and therefore the answer is divergent. Here we use the comparison test. Okay, answer is divergent. Question number 58. The series 1 minus 1 by 3 plus 1 by 3 square minus 1 by 3 cube plus etc. Here the answer is absolutely convergent. Question number 59. The series sigma 1 by n log n power p is divergent if dash. So here we have use Cauchy's condensation test, and the answer will be p less than or equal to 1. Question number 60. The series 1 plus r square plus etc. is oscillate if the answer is r equal to minus 1. Okay, thank you students for watching today's class. I hope this class is very useful to prepare section A type questions, that is multiple choices questions. If you have any doubt or queries or confusion, try to share through comments. Thanks for watching.